So chapter 3.7 example 20, a sequence A1, A2, A3 is defined by, so we've got A1, the first term is P, and our definition for our sequence is AN plus 1, the next term, is equal to the current term squared minus 1. And we're told P, the first term, is less than 0. So show that A3 is. So we need to start A1 equals P. A2 is our current term, P squared minus 1. So we've substituted in our current term. And now, to get to A3, we've got our current term, which is P squared minus 1, substituted in. So we've got P squared minus 1 squared, take away the 1. Yeah, so we've substituted in the current term, squared it, and then take away the 1. So we've now got P to the 4, you can use a grid if you need to, minus 2 lots of P squared plus 1, expanding the brackets, take away 1, which is P to the 4 minus 2P squared as required. Okay, so part B. Given that A2 equals 0, find the value of P. So we take the question in effect, A2 equals 0 as our state phase, and we can substitute in for A2. So that will give us, A2 is P squared minus 1 equals 0. Yeah, so we've substituted in P squared minus 1 into A2 equals 0. So P minus 1, P plus 1 equals 0, so P equals plus or minus 1. But what were we told in the question? The usual thing, make sure you go back and read it, where P is less than 0. So since P is less than 0, P must equal minus 1. Part C. Find the sum from R equals 1 to 200 of AR. Sum from R equals 1 to 200 of AR. Well, we've done a few things like this using summation notation before. And we know that first find a few terms and then think. Yeah, first find a few terms, then think. Yeah, we're looking for a pattern. So A1 we know is P. Yeah, so when R is 1, yeah, when R is 1, A1 we know is P, and P equals minus 1. So this is R equal to 1. So we get P equals minus 1. Plus P2, we worked out, didn't we? A2, given that A2 equals 0. So this is R equal to 2 here. R equal to 2, we get 0. Okay, so we now put 0 in, and 0 squared 0 squared minus 1 is minus 1. So when r equals 3, we get minus 1. And you can see now that the pattern is going to be sort of oscillating. 0 plus minus 1 plus 0, etc., etc. So if we add those up, alternate terms are minus 1. How many terms have we got? Well, the number of terms is equal to 200 minus the 1, the difference between the top and the bottom, and then add 1, because you have to include both ends. So we've got 200 terms, but half of those are negative 1. So it's 100 times negative 1 equals negative 100. Part D. Write down the value of A is A199. So A199. So we're on 199th term. And the key thing to pick out here is, well, we can see that they're oscillating. So it's either going to be minus 1 or 0. And this is an odd position. Well, all the odd positions, if we look up here, first is negative 1, third is negative 1, fifth is negative 1, etc. So the 199th term is also going to equal minus 1.